Right, hi, welcome back to maths. Got some questions here for you to try on the whiteboards. Answer them and hope you get them right. Follow on from what we did the other week. So if you can pause and now unpause, here are the answers. Give you a moment to check them. Okay, right. This is a bit of a start to what we're doing, this new topic, polynomials. Introduction to something called long division I'm going to teach you. So just on your whiteboard, if you can hold them up, and teacher, probably Glenda, will just check these for you. X times something gives you x to the 4. What is it? Hold your board up. I should put x to the 3. Next question. Hold your board up. What's x times something gives you 2x to the 3? Next one. X to the 4 times something gives you 4x to the 5. Hold your board up. Next one. 2x to the 3 times something gives you minus 6x to the 5. Hold your board up. Next. 5x times something gives minus 25x to the 6. Next. Expand that. Hold your board up. Next. Expand that. Hold your board up. Random turn if mine are wrong or right, probably. Hopefully I've got them right. Next. Expand that. Hold your board up. Next. Oh, that's a little beast. Probably getting your calculator out now, and I wouldn't blame you. But this isn't the point of all this. But if you know long division, great. But you probably, like me, weren't even taught long division when we went to school. But I'm going to show it you in a minute. But just answer that one. You're probably using machine. There's any whizzes here who know such a thing. Glenda will. 191. Right, we're going to look at long division. It's not putting it in the calculator. That's not really how people used to do it. So this next slide shows you how long division was done in the olden days. I'm glad to double tell me if I get this wrong now. Work out that thing divided by 25 using long division. And this is what I think long division is. How many 25s go into 2? None. Oops, change my pen. So I write 0. Carry on. How many 25s, carry the 2. How many 25s go into 26? And you'd say, well, so if you like, cross that out and carry the 2. How many 25s go into 26? Well, you'd say 1. I don't do remainders, just 1 here. And this is 1, and in the timer things, that's 100, isn't it? So long division says then you do 100 times a 25. Now that gives you 2500. That's what you've got already, so you chop that away from the original question. So 2 take 2, gone. 6 take 5, 1. 7 take 0, 7. 5 take 0. Should have gone the other way around, shouldn't we really? But anyway, 175. Then you start the game again, so with a different colour. You'd say, how many 25s go into 1? Well, it's not going to go. So bring the 1 across. How many 25s into 17? None. Put 0 up there. And then carry the 17. How many 25s go into 175? Well, that's 4, 5, 6, 7, isn't it? And then you do 7 times 25, which is 175. Chop that away from 175, 0, all done. So basically, 2675 divided by 25 equals 107. It's long division. Let's do another. All right, so this one. How many 12s go into 3? None. How many 12s go into 38? Well, that's 36, isn't it? So that's 12, 24, 36. So that's 3. Don't say with a remainder, forget that. And then basically this is 300. So we say 300 times 12, or 3 times 12 is 36. That's going to give me 36, but it's 100, so it's 0, 0. 300 times 12. Chop that away. 3's are going to go. 6 take 8 will be 2. Oh, it should go from this end really. 5 take 0 is 5. 7 take 0 is 7. 8 take 6 is 2. And then we play again. So new colour. How many 12s go into 2? That'll never go. So it's still. So you carry the 2. How many 12s in 27? Well, how many 12s in 27? That's 2, isn't it? 2. Don't do remainder 3. Forget that bit. What you're going to do now is 2 times 12. That is 20. Which is actually 20. It's in the 20. It's in the tens column. So it's 20 times 12, which is 2, 24, and a 0. Chop that away from the blue bit there. It's 2 tick. Well, 5 tick 0. 0. So 5 ticks is that 5. Ooh. And 7 tick 4, 3. 2 to 2 gone. Then you go again. How many 12s in 35? Well, how many 12s in 3 doesn't go, whatever it is. How many 12 carry the 3? How many 12s in 35? That will be, it's not 36, is it? So that's only still going to be 2. Should change colour. Come on, be a devil, get all your felt tips out today. How many 12s in 35? Well, there are 2. And then you go 2 times 12, that's 24. Oh. And then chop that away, my bit's in the way. 35 take 24, 5 take 4 is 1, 3 take 2 is 1, and 12, obviously 11's smaller than 12. So basically what we've got here, they will say that 3875 divided by 12 would equal 322 with remainder 11, or you could say with 11 over 12. That's impressive, long division for first thing today. Right, let's see if we can make that algebraic long division. Ooh, that'll be interesting. So hopefully we can find this in your folders. You've been given it before, so find these sheet lesson notes. And we're going to be doing polynomials and factorisation 1. Please have a look in your bags if you've, because you have been given this in your folders. You did take them away, and there's a worksheet that goes with it as well, which we'll meet in a minute or two. But if you haven't got it because you've lost it or eaten it, or you've been such a bad pupil that you've, I don't know, ate your dinner on it, then there may be the odd one spare at the front. Glenda will have a look in the AS Core Maths box that should be towards the top there, like a wallet, a little plastic wallet with a few of these in for anybody who wasn't there when I gave them out, basically. Right, so today we're going to be factorising polynomials using long division. We're going to know how to factorise polynomials by inspection, and we're going to understand and be able to use the fact theorem to see whether a linear expression is a factor or not. We might see some other method of doing rather than long division if you really hate it, but I want to teach it because I think it's lovely and it works for everything. So I don't want to see any of that rubbish box methods, or they don't like those. Glenda might allow them, but no, don't like box methods. So I'll show you a couple of methods to do dividing polynomials. Hopefully you like one of them. But long division is my favourite, and so I shall try and persuade you that it's the way to go. So have this sheet now. Hopefully everyone's got one. And off we go. Right, algebraic long division. In this lesson, it will be helpful if you do algebraic long division. So if we had to divide that by that, we'd set it up with this bus shelter method, wouldn't we? Okay, this thing is called the dividend. You don't really need to know these names, but it is interesting. This thing is called the divisor. And the answer that we get at the top will be called the quotient. Will appear on the top. That's the answer. Okay, so we'll try this question now. So long division, what we do, got different colour pens, get them ready. We'll pick this here and we say how many times, or what do we times x by to make the first term you've got here? What would we times x by to make 6x to the 3? Yeah, that's 6x squared, and put that above in the answers, above the 28x squared, to line them up. And then what we do with that, don't talk about remainders, we say what's 6x squared times these two? Well, 6x squared times x is 6x to the 3, and then 6x squared times 5 gives us 30x squared. And then we chop those away from what's above, so we subtract all of this from what's above. So 6x to 3 take 6x to 3, 0. That will always cancel out. Then we've got 28x squared take away 30x squared. That gives us minus 2x squared. Then we've got minus 7x take nothing, so that's minus 7x. And then we've got plus 15 take away nothing, which is still plus 15. Done. And then we start again. So here's the time to use the parents of both your lovely colours. So new colour, start the game again. What would we times x by to make this first term here? Yeah, minus 2x. Yep. So then we do minus 2x times x, that's minus 2x squared. Then we've got minus 2x times 5, that's minus 10x x, and we've got to subtract all of that from what's above. That will disappear. Now we've got minus 7x, take away minus 10x. It becomes plus, doesn't it? So minus 7x plus 10x gives you 3x. And 15 take away nothing is still 15. We get to go again. How wonderful. So get a new colour pen if you've got one. And we'd say, what do we times x by to make this first term here? X times something makes 3x. Yeah, you've got it. 3. So then we times this by these two here, so we get 3x. And then 3 times 5 is 15. Subtract away, everything's 0, so there's no remainder. That means that 6x cubed plus 28x squared minus 7x plus 15 divided by x plus 5 would give us what's on the top there, what we call the quotient. So that divided by that, I have to go in black, just equals 6x squared minus 2x plus 3. That's our answer, no remainder, all of that. Lovely. Do another one. A shorter one here. Let's see what we're doing with this one. So if we carry the same method, we'd say, what do you times x by to make 2, this term here, 2x? Well, that would just be 2, won't it? Let's put the 2 above there. Then we do 2 times these, 2x minus 2, subtract that away from what's above. So 2x take 2x, gone. 6 take, so it becomes 6 add 2, which is 8. So answer is 2 whole ones, but this time we've got a remainder. So we've got plus a remainder of 8, which still got to be divided by x take 1. So that's the answer there when we have a little remainder on it. Could do that one by inspection. If Glenda wants to pause and do it by inspection, you can. But I don't want to confuse you at this stage, really. Let's move on. Right, example 3, one more of these, and then might have you trying some. So start off. Here we go again. If you didn't quite get it last time, let's hope this helps. So you say, first term here, what would you multiply x by to make 9x cubed? Yeah, that'd be 9x squared. Then we time the 9x squared times these two things here. So that'd be 9x cubed minus 2 times 9 is 18x squared. Then we subtract them from what's above. That take that gone. Oh, not the bracket round. That take away negative 18, so it becomes plus 18. So 7 plus 18 is 25 x squared, and then 4x has nothing subtract from it, and the minus 2 has nothing subtract from it. So you change pen and start the game again. Keeping with the x. What do we multiply x by to make what's in here? 25x squared. Well, that would be 25x, wouldn't it? So it's 25x times the x makes 25x squared. Then 25x times minus 2 is minus 50x. Subtract them away, gone. And remember doing that, subtract that. So it ends up with plus 50. So that's 54x. And we've still got minus 2 with nothing subtracted from it. And it's so exciting, we get to go again, yes. So more colours if you've got them. Green. What do we times x by to make this term here? Well, that will be 54. And then we go 54 times x is 54x. 54 times minus 2 is minus 108. Subtract those from there, that always disappears. That subtract, remember all of that, subtract negative, so we add it, gives us 106. So our answer to this question, I'll have to write the answer above it. So, oops, answer coming up here. The answer would be 9x squared plus 25x plus 54 with a remainder, so plus a remainder of 106, still to be divided by x take 2. And there we have long division. I hope you like it. Very complicated and very weird when you see it for the first time, but it is quite a lot of fun. We have got some on some whiteboards for you to have a go at. So Glenda can pause the video when, this is Glenda, can pause the video when she wants before the answer pops up. So we're going to try some on the whiteboard, and then there'll be this worksheet that should be in your folders. I gave them out. Again, there'll be the odd one spare for those who didn't get any when we handed all the sheets out. So if that's you, you might need to come and get one. It's got 3 questions on it. It says algebraic long division traditional method. So we're going to do the whiteboards first, but there might be an error on your sheet. Just can you have a look at it? Question 1, 2 and 3. Question 3, it should say not 24. That should be a 25. I'm not sure if I changed them on the sheets or not. That should be 2x to the 3 plus 6x squared minus 2x plus 25. That will help you in a bit. If you don't change that, you'll have a horrible question. Right, anyway, the whiteboard ones, let's get on with those. Try that with the long division. Please pause the video and have a little go before I pop the answer up. Right, unpause. Here it comes. They've done it in steps there. They show you how to write it out first. Then they show the first step, what happened. Here, what did you times x by to make x to the 3? Well, it was x squared times those 2 by x squared, got those 2, subtract them away, gave you that. Then rather than carrying on, it's done it as a new step, basically saying, draw on that one, what would you times your x by to make minus 2x squared? Well, it's that. And then do that step, that times that gives those 2, subtract them away and you get that. And then the other step here, they've now started, what do you times to make times 2x? Well, it's 2 and you get that. And then if you want to write your answer out, that's what the answer would be. Okay, new question. Try that one. Please pause. Unpause. Here comes the answer. Would we like another? I think we might have one more. Try that one. If you want to pause and unpause the answer. You want to have a stare at that? What happened? And then you're going to get the worksheet out. So if you want to stay at that for a bit longer, you can do. Can you now pause the video and try the worksheet? That was the worksheet we just looked at before. This one here where you've got, well, I've got the answers on mine, but oops. That worksheet, you should have it, says algebra, long division, traditional method. You should have that. I gave them out. It might be a different coloured sheet. And if you haven't, there might be the odd spare for those who were missing when I gave them out in that same wallet that had the PowerPoint slides on. So we can pause video now, and I'll shut up and have a go at those 3 questions. Okay, unpaused. Here are the answers. There's number 1. Here's number 2. And here's number 3. Oh, I wonder if that got picked up. There was an error on the original thing there. Right, super. Okay, so if you've hated the lesson so far today, this might save it. So, algebraic long division. There is an alternative method to long division. However, we need to be aware of the factor/remainder theorem first. The factor theorem, not tractor, factor. Factor theorem says that if x minus a is a factor, then f of a will be 0 and vice versa. And if f of a does not equal 0, this tells us that x minus a is not a factor. And in fact, the remainder will be what f of a equals. Wow, right, that probably made not a lot of sense to you. And there was a word in there I didn't read because it seemed daft, but never mind. Let's have a look at these examples, it will make it clear. So if we were to divide this long polynomial here by x plus 5 with long division, would there be a remainder or not? One way to find out is to do f of minus 5, not plus 5 but minus 5. So if I put that into there, I'll get, you'll want your calculator for this, 6 times 6 lots of times, it'll be minus 125, won't it? I can do any maths, plus 28 lots of 25 minus 7 lots of 5, which is 35, and plus 15. What do you get when you put those together? So you want your machine to work that one out. A few adds. Comes out to be, yeah, 0. So that does mean that x plus 5 will be a factor of that because there'll be a remainder of 0. Back with that, we did that question in fact a bit early, if you remember, in the lesson, and it was a remainder of 0. Question example 2 that we did in the lesson, did that have a remainder? Can you remember? Look back in your notes, let's have a look. Look back, where were we? A few slides ago. Example 2. I did do it. I think there was a remainder. I think the remainder was, it 11? Lost it now, but let's have a look. So with this one, you're looking to see if this is a factor. If you were to find out if that's a factor, does it go into that with no remainder or not? We try f of 1. two lots of 1 plus 6 is obviously not 0. In fact, it is 8. So was the remainder 8 that we had in that question? Yes, it was 8. Fantastic. So that's given us the remainder. There were 8 left over. With this one, this is question 3 that we did. Was the remainder? We look back. Example 3. Yeah, I think there's a remainder of 106. Let's have a see if that comes out this time. So if we try and do that one, we would put f of 2. So f of 2, so that'd be 9 times 8 plus 7 times 4 plus 8 take 2. And that comes out in on your calculator as, press a few buttons. Yes, 106. So it wasn't a factor and there was a remainder of 106. Useful. Algebraic long division by inspection. So they call this method inspection. I call it spot the difference. But anyway, they call it by inspection. So we've got this long polynomial to divide by x take 2. So we're going to use the fact that x take 2 times something plus possible remainder will equal that. And it'll have to be a quadratic here, won't it? Because a quadratic times a linear would make an x to the 3. But we don't know what this quadratic is yet, and we don't know if there's a remainder. So first job would be to check to see if there is a remainder when we divide by 2, x take 2. So I'll find f of 2. So f of 2 equals 6 times 8 minus 17 times 4 plus 2 9's 18 plus 2. What does that come to, anyone? Yeah, hopefully somebody's pressed the button, not just waiting for me. It comes to 0. So yes, this will be a factor and there'll be no remainder. No remainder. So we'd have to write therefore x take 2 is a factor. There is no remainder. Right, so we don't need to write it with the remainder, so we've written it here below without the remainder. Right, so we've got this thing with no remainder. So it's like a game. They call it inspection. I call it spot the difference. And we have to make the left-hand side equal to the right-hand side. So looking at this, some of them we can guess straight away. We've got 6x to the 3 here. And we need 6x to the 3 on this side. So the only way of making an x to the 3 is timesing that by that. So that means A must be 6. The other one we can get is the constant. We've got 2 on this side. We need 2 on this side. So what must C be to make, the only way we're going to get a constant is doing that times that. Anything else produce something with an x in. That means C must be, yeah, you've got it, minus 1. So the only one we need to put a bit of effort into finding is the B, the bx. To do that, we'd have to equate either the x squared or the x terms. So we've done the constants and the x to the 3's, and that didn't help us find B. If you don't feel too confident about looking at this side of the equation, you could multiply these two brackets out. So I'll do that. 6x to the 3 plus bx squared minus x minus 12x squared minus 2bx plus 2. So if we're equating the x terms, so on the left hand side we've got 9x. On this side we've got minus x and minus 2bx, haven't we? That's all. So if we get rid of the x, divide everything through by x, because we're only looking at the coefficients anyway. So if 9 equals minus 1 minus 2b, take that over there, we get 10. Divide by minus 2, and you will get b equals, minus 5. So we've found all the letters. Now what we can say is if we divided, go back up here, it's like a bit of moving things around. It's at times at the moment. So if you take that under there, you divide this polynomial by x take 2, then it will in fact equal ax squared plus bx plus c, which in our case we found it as 6x squared minus 5x take 1. Answer all done. However, there could be a remainder sometimes. Now, in AS Maths, I don't think you get a remainder, I'll be honest with you. But we're going to look at it because it's interesting. And it's best to know, because in life there might be a remainder at some point. So it says, work out this thing. Right. In fact, anyway. So we need to know how to do it, really. So we've got this long polynomial and we divide it by x take 9. So first of all, we need to find out whether there's a remainder. So we do f of 9, positive 9, to see if there is. So look, putting it into our original polynomial, 2 times 9 to the 3. What's that? Oh gosh, 81 times 9. Don't know that. 729. Minus 12 times 81 minus 60 times 9 plus 53, and that comes to 1. Hopefully somebody's shouting it out. Minus 1. Therefore, x take 9 is not a factor. And there will be a remainder of minus 1. Right. So we've got a remainder this time. Interesting. So we know that the remainder is in fact minus 1, so we can put that on actually. So plus minus 1. Right. Now it's the same game, but a little bit harder when we're looking at the constants. First of all, right, look to find the x, spot the difference for the x to the 3's, because that's nice. We've got 2x to the 3 here, and this is going to be a quadratic. So it means that a must be, x times what makes 2x to the 3? Well, it's got to be 2x squared, hasn't it? To find c, a little bit harder, not too much harder. Still not too bad. We'll look at the constant terms. We've got 53 on this side. On this side, we get what the only way to make a constant is the minus 9 times the c. So that makes minus 9c. But you've got to remember there is a remainder of minus 1 now. So you've got to take that into account. Take them over. 54 equals minus 9c. Therefore, c must be minus 6. So we can put minus 6 there. And then put our bx in. To say if you don't feel confident about things, oops, we've got minus 1 there, I don't like that, plus minus 1. If you don't feel too confident about things, you can multiply out those brackets. What we'd have 2x cubed plus bx squared minus 6x. And then you've got a 9 through, so it's minus 18x squared minus 9bx plus 54, take 1. So now we could go along and we can equate the x terms to find b. So on this side we've got minus 60x. What space I've got here? Oops, not much, but I'll do that a bit smaller. Minus 60x on this side, and on the other side we'd have what x terms have we got here? We've got minus 6 and we've got minus 9bx. So forget the x's are there, take the 6 over there, to be plus 6, so you'll end up with minus 54 equals minus 9b, and therefore b will equal 6. So our answer to this thing is, in fact, to write really small, 2x squared plus 6x minus 6 with our remainder of minus 1. So minus 1 over what we were dividing by, which was x take 9. So that's our full answer. Lovely. So that's an alternative to long division. So if you didn't like the first one, you'll like this then. Or you might like both. Let's hoping. It's me hoping, I should say. Right, on your whiteboard, try that one. I'll be quiet. And Glenda or whoever it is will pause the video and give you a chance to have a go. Okay, one pause time. Here comes answer. I hope. That remainder of, well, where's a factor? So you just equaled it to that. You got A and C. Then you had to go and find B. So the answer is popping up the top. Answer is just 2x minus 8x plus 7. Here's another one for you to try. Again, I've been kind with no remainders. You'll find out. Oh, shouldn't have said that, should I? Quite happy. Right, have a go at that one. So pause the video. Unpause. Here comes answer. There we have it. Final answer. Oh, sorry, I went a bit fast then, didn't I? Hopefully you got it. Right, last thing just to mention before I disappear for the weekend. Use long division to find, if it tells you you've got to use long division, you have to use long division in questions. So this question says use long division, so we've got to use long division to find the other factors when given x plus 1 is a factor. So we're given it's a factor, so we know we're going to get a remainder of 0. If we don't get a remainder of 0, we've gone wrong. So long division, off we go. We like that. Well, I like it anyway. Get to use all my colours. So we start off with this one. What do we times x by to make 2x to the 3? Well, that's going to be 2x squared. Then 2x squared times these two. 2x to the 3 plus 2x squared. We now subtract those from the ones above. That always goes. 7 take 2 is 5x squared. And there's nothing to take away from these two, so we'll just copy them down. Then we get to change colour pen. Woo! Blue. So we start again. What do we times x by to make 5x squared? Well, that would be 5x times these by 5x times these two. So we get 5x squared plus 5x and then we subtract those away from those above. That take that always goes. That take that, minus 3x. And minus 3 take away nothing, just minus 3. And then we get to play once more. Another colour. Right. What do we times x by to make minus 3x? Well, that's minus 3, isn't it? And then times those by minus 3, minus 3x minus 3. Remainder 0. Woo, we've got it right. Let me head down out of excitement. Right, so we know that we've got basically find the other factors. We should find the other linear factors. So the two factors of this, one is obviously x plus 1, and the other is this quadratic factor. But does that factorise, I wonder? Is there a way of doing 2x something and x something? Oh, a bit tricky. You can cheat on the machine if you want to get the two answers and then read them back. So if you do that, you go to equation mode. You then press polynomial, degree 2, put in 2, 5 and minus 3. It tells you the answers are a half and minus 3, so we need that one to be, because that's a half, it'll be 2x minus 1. And this answer is 3, so it'll be plus 3. That should work. So we've done it. We've got one factor x plus 2 and the other factors are these two here. So that's all done. Me done. Hopefully you've understood most of this today. I'm sure there'll be an option to record, re-listen to it on Teams if you didn't. Replay it on Teams if you didn't. Or Glenda will have done a far better explanation perhaps. And good luck. There is an exercise you could do, it's probably the end of the lesson, but there's an exercise you could do at home if you want more practice on this, because I'm sure it'll appear in some homework at some point very soon. Right, take care and perhaps see you next week. Bye bye.